Hello, welcome my wonderful students. So today we are going to learn about chemical reactions and chemical equations. So before I begin the topic, let's see this picture and try to figure out what is happening in here. So here we can see there is milk, right? And this milk is being turned into curd, right? What is happening here? Milk is our original product and it is changing into something new, isn't it? Same for rusting of iron. Iron was there, and due to the environment, due to the moisture and air, it changed into rust. Fermentation of grapes, we take grapes, turn it into the juice, and then ferment it, and we get something new. Same with the cooking of food. We have raw food and then we cook yummy dishes with it and we get something new. That is a dish. Then in our body, we get food and we digest it and we get something new. What we get? Energy, right? We get nutrients and energy. So something that is food, the original thing has been changed into something new. Same for respiration. When we inhale oxygen, and when we exhale out carbon dioxide. So here also we are starting with something original and that is getting changed into something else, right? So what is happening in all these activities is a new substance is getting formed after the process, and such kind of process is called chemical reaction. So let's see how we define it. A chemical reaction is a process in which reactants are converted into new substances which are called as products, right? What are the new substances? Products. And our original substances are reactant. So reactants are changing into product. And how is it happening? By rearrangement of atoms, right? So in our reactant there are certain atoms which are arranged like this, and after the reaction some rearrangement is happening and new substance is getting formed. Do you remember? You must have seen this activity, burning of magnesium, right? Burning of magnesium ribbon. So let's go to that. Here what we do, we take a magnesium ribbon and burn it. So after burning it, what we get? White powderous substance, and that is magnesium oxide. We get magnesium oxide. So here from our reactant, that is magnesium and oxygen in the air, these are reactants, and we are getting product, that is magnesium oxide. So here our product is magnesium oxide. Okay students, so here is a mindful minute. Can you answer this question? When a magnesium ribbon is burned in air, a white powder is formed. Which statement is true in this? A. A new substance is formed in this reaction. B. It is example of a chemical reaction. Okay. So it's example of a reaction. C. A new product is formed. And D. All of above. Yes, try to write your answer in the comments. Yes, very good students. I know you are able to get it. All of above are correct. Very good. So here in this 20 minutes, we are going to revise and relearn all the things starting from writing and balancing chemical equation, identifying different type of chemical reaction, distinguishing between exothermic and endothermic reaction, and explain displacement and double displacement reaction, And also we are going to understand about oxidation and reduction processes or reactions. Let's start. So here you can see what happens during a chemical reaction. So some reactants, they can change their color after being added to each other, after reacting, they change their color. So here you can see blue color is being changed into green. So many reactions show change in the color. Secondly, they can also show change in temperature. Like when you add quicklime into water, the temperature rises. Hmm. So in this kind of reaction, temperature or energy is released here, right? So such a reaction is called exothermic. What is a exothermic? The reaction in which energy is released. Okay. And what is endothermic? The reverse of it. In that kind of a reaction, the energy will be absorbed. Like for cooking, right? When we cook food, we give it energy, right? So that kind of a reaction is endothermic. Can you give me some examples of exothermic, endothermic reaction from your day-to-day life? Please comment down them. All right, now let's move to the third thing which happen in a chemical reaction. In some reaction, when you add reactants together, you will see bubbles of gases. So you see evolution of gases like HCl and zinc. These two reactants combine and they form hydrogen gas bubbles. In some reaction, you can see insoluble substances being formed. Such substances are called precipitates. So, for example, in this, you can see Ki, potassium iodide, is reacting with lead nitrate, PbNO3 twice, and they are forming the precipitates. In some reactions, you will see change in the state of reactants. Like reactant can be solid and after reaction they are changing into liquid. Or in some you will see the solid is changing into vapor or liquid is changing into vapor. So change of state is also a characteristic of chemical reaction. So make sure you make this list. What happens? The characteristic of a chemical reaction. What happens during reaction? There can be change in color, there can be change in temperature, heat can be released, like in the reaction I showed you here. In quicklime and water, heat is released and it can be absorbed, like in cooking of food. Then the third, evolution of gases. And the fourth is formation of precipitate and change in the state. These are the characteristic of chemical reaction. Now let's move forward and let's understand about chemical equation. A chemical equation is a symbolic representation of a chemical reaction. And to symbolize it, we use chemical formulae of reactant and products. So, students, we learned one reaction, right? What reaction was that? Magnesium was reacting with oxygen of air. So, magnesium and oxygen were our reactants. And it was forming a white powder substance. That was magnesium oxide. That is our product. So can you see what we are doing in a chemical equation? We are writing the reactants at the left hand side of the equation and products at the right hand side of the equation, and we are representing the change with an arrow. An arrow head points towards the product. So this representation, this symbolic representation of a chemical reaction is called chemical equation. I hope you all understood and recall what is a chemical equation. Now students, our chemical equation is correct when it is balanced. What is balanced? Let's see this equation. So here, two molecules of hydrogen are reacting with one molecule of oxygen and they are forming product, that is water, but two molecules of water. Now how it is a balanced equation? So look at the number of hydrogen atoms in the reactant. In reactant, there are two hydrogen molecules and one molecule of hydrogen has two atoms. So, total there are four atoms of hydrogen in the reactant side. To make this equation balance, there should be four atoms of hydrogen in the product side as well. Let's check whether we have that. So, here we can see we have two atoms of hydrogen in water and there are two molecules of water. So total four hydrogen atoms are there. So that means hydrogen is balanced on both the sides, right? Okay. Now let's see for oxygen. In oxygen, in reactant side, we have only two atoms. Let's check at the product side. In product, there is one atom of oxygen in one molecule of water. But we have two molecule of water. So that means we have two oxygen atoms, right? So two both sides. So here quantity of element and their atoms remain same before and after chemical reaction. So students, this is a balanced chemical equation. What is a balanced chemical equation? In which number of atoms of each element is equal on both the reactant and product side, and it is on basis of law of conservation of mass. Students, this is important. According to law of conservation of mass, atom can neither be formed, can neither be destroyed. Atom only rearranges in a chemical reaction. That's why the number of atoms on both sides, that is reactant side and product side, should be equal for each element involved in that reaction, right? So that kind of equation is balanced chemical equation. So now let's see how we balance a equation. So earlier we write our equation randomly, like we wrote that magnesium wala equation, Mg plus O2 giving us MgO. If you observe it carefully, in the reactant side there is only one atom of magnesium, but in the product side also one atom of magnesium. So magnesium is balanced, no problem. What about oxygen? In the reactant side there are two oxygen atoms, but in the product side only one oxygen atom. So such a equation is unbalanced. The atoms are not equal, right? So we need to balance this equation. So first, balance oxygen atom by putting coefficient before MgO, right? We cannot change the formula of any compound or any element. So we can only add coefficient, right? So this is very important point, that to balance we can only add coefficient. We cannot change the formula of any compound or any element, right? So we can write 2MgO, no problem, right? So if we write 2MgO, it makes two atom of magnesium in the product side and two atom of oxygen in the product side. But what about our reactant side? Are there two atom of magnesium? No. So that means it's still unbalanced, and to balance out, we need to put a coefficient before Mg also, right? So now we have a balanced equation. We have two atom of magnesium at both the sides and two atom of oxygen at both the side, both reactant and product side. So what is the key point? A chemical equation is balanced when number of atom of each element is same on both sides. Now let's move forward to types of chemical reaction. There are four types of chemical reaction. First is a decomposition reaction, in which a simple compound, a single compound breaks and it forms two or more products like AB. AB is a compound which is breaking into A and B. Okay. Then combination reaction is just the reverse of decomposition. In combination, two or more substances are coming together and forming a single substance. In product, we have single substance, and reactant, we have two or more substances reacting. Okay. So decomposition and combination, they are reverse of each other. Now let's move to next reaction, that is displacement reaction, in which atom of one element, which is highly reactive element, displaces or pushes out the atom of other element from its compound. Like here, AB was a compound and C is the more reactive element. It's displacing B from its compound. Okay. So only one change is, a change is happening between B and C. But in double displacement, it is going to happen two times. How? Let's see. So AB and CD, in this, there is two times displacement happening. How? D is displacing B and B is displacing D. Got it? So there is positive ions which are being exchanged between two compounds. Okay? Ion exchange happen in double displacement reactions. Now let's revise these reactions once again in form of questions. Yes, students, I know you will be able to do it. So here is the first question. What type of reaction is this? If you see it, this is A, this H2, 2H2 is A, and oxygen is B, and they are forming AB. What kind of reaction is this? Combination reaction, isn't it? Two or more substances are forming a single compound, a single product. This is a combination reaction. Very good, students. Now let's answer this in the comment box. Lead nitrate, when we heat it, it breaks down. It breaks down into three different compounds: lead oxide, nitrogen dioxide, and oxygen. What kind of reaction is this? Very good, students. So this kind of reaction is decomposition. Very good. This is an example of a thermal decomposition where we are heating substance to break it down. Do you know any example of any other kind of decomposition where we use some other energy like sunlight or electricity? If you know, please comment down in the box. Let's go to the third question. What kind of reaction is this? Yes, exactly. Very good, students. Those who are writing in the comment box. So here, iron is displacing copper, right? So this kind of reaction is displacement reaction. Very good, students. Now fourth one. Very good. Here, exchange of ions are happening, right? So here we see sulfate and chlorides are exchanging sodium and barium ions. So this is a double displacement reaction. Double exchange is happening. All right, now we come to most important reaction, that is oxidation and reduction reactions. Oxidation, as the name suggests, is, see, it starts with oxy, means gain of oxygen, and loss of hydrogen. So in oxidation, loss of hydrogen happen. Let's see how. In this reaction, methane is losing hydrogen atoms and changing into carbon dioxide by gaining oxygen. So there is loss of hydrogen from methane and gain of oxygen, right? So this is an example of oxidation reaction. Methane is getting oxidized here. Now let's move to reduction. Just opposite of oxidation. Here gain of hydrogen and loss of oxygen. Like here, copper oxide is losing this oxygen here and changing to copper. So loss of oxygen is happening. That's why copper oxide is getting reduced into copper, right? So key point here is oxidation reduction occur simultaneously. If something is getting oxidized, The other reactant must be getting reduced. Only then this can happen. So both reaction happen together. Where you will see oxidation, reduction will also be there. Okay. Now let's move forward. So have you seen in real life some reactions like this where something is getting oxidized? You can name few in the comment box. Very good, smart people. You can see there is rust happening in this car, right? So, rusting, very good. Any other examples you know? You can write in the comment section. Very good, students. So, we are heading towards corrosion and rancidity. Now, let's see what is corrosion. Corrosion is gradual destruction of metal when it react with oxygen, moisture, and other chemical, like in iron. Rusting happen, that is example of corrosion. Tarnishing of silver, if you see silver changes into black kind of a substance, that is because of corrosion. Okay. What is rancidity then? Uh, See, corrosion is happening to the metals, destruction is happening for metals. If that destruction or spoilage is of food, such as fats and oils, then that is rancidity. So, in this, fats and oil oxidize and they start giving very bad, pathetic, stale smell. Right? If you have used very old chips, so they smell kind of weird, right? Old chips, old peanuts, or something which is made of butter. If you see, after some time, try to eat it. Don't try, okay? So if you smell that, you will find that okay, this is not good. We should not eat it, right? So what has happened there? The oxidation of fat and oil in those chips has happened, right? So corrosion and acidity are undesirable processes. We don't need them, right? But they happen because of the environment around us. Okay. I hope this is clear. So here is a simple question. Which of the following example of rancidity? Rusting of iron is corrosion. Very good, student. Tarnishing of silver is also example of corrosion. Very good. And spoiled butter is example of rancidity. And galvanization of iron, this is neither corrosion, neither it is rancidity. Okay, so here key point is corrosion and rancidity both are undesirable processes that affect metal and food respectively. That's all for this session, students. I hope you are able to recall all your topics, and very soon I will be bringing a short video of your next chapter. For that, you need to subscribe and like my channel so that you can get good content like this. Thank you so much.